Now we are going to discuss about object-oriented software engineering. In Unit 1, we have the introduction. In introduction, we are going to discuss about introduction to software engineering and introduction. The size and complexity of software are increasing day by day. Conventional approaches such as waterfall model, which lacks iterations and reuse and difficult to incorporate change requirements of software design and implementation may not be effectively applicable. A large size software project requires more thorough and systematic approaches. Also, to build every software system from the scratch that results into a costly software system including very high maintenance costs. An object-oriented paradigm may address such issues. First, we are going to discuss about what is the definition of software engineering. The software engineering is a product of two terms. The one is software and another one is an engineering. The term software is a collection of programs which has organized instructions and code written in any of various computer languages. Engineering is the application of scientific and practical knowledge to invent, design, build, maintain, and improve frameworks, processes. Then the next definition of software engineering, which is given by Fritz et al. In the year 1968, is the establishment and use of sound engineering principles in order to obtain economically developed software that is reliable and works efficiently on real machines. Another definition given by Abram et al. In the year 2004 is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software and the study of these approaches, that is, the application of engineering to software. So, the main objective is to deliver good quality software to the customer at a low. The software product can be obtained by gathering the requirements, then performing the system analysis, and then system design, and then code design, and then testing. After that, if any updates required, that will be done. Then deployment, and after the delivery of the software product, the maintenance, which also be included in the software process. So we'll discuss about the difference between a program and a software. A program is a set of instructions written for a specific purpose. However, software is a combination of programs, documentation, that is documents produced during development, and operating procedure manuals, that is delivered with programs to the customers at the time of release. So the software is a programs, documentation, and operating procedure and manuals. These are all the parts of the software. Documents may be produced during software development and used for maintaining the software. Some of the documents are software requirements and specification document, software design document, test plan document, test suite document, and source code. Operating procedure manuals are prepared to help the customers to install, operate, and maintain the software. They are delivered along with the programs at the time of release. Some of the operating procedure manuals are installation manual, system administration manual, beginner's guide manual, system overview, and reference guide. Again, the fault will be increased during the wear out. But in the case of software, there is no wear out phase in software as shown in figure 1.3, and there is a burn-in phase and also the useful life phase for different type of inputs for a long period of time. And the next characteristics is the flexibility of software, any change possible at any time without much difficulty. Making changes in software is easier as compared to the hardware, and such changes may be done in a proper study and analysis of its impact on other parts of the source code. Then next important characteristics is the reusability of software. The reusable components are very common and popular in practice and also reduce the time and cost of manufacturing through maintaining the quality standard. Reusability is the process of integrating the already built, well-tested components in the new software under development. So by reusing the existing source code, the development effort and cost of development and testing are reduced. And the reusability which has introduced component-based software engineering, that is called as CBSE. Many popular commercial off-the-shelf components use the concept of object-oriented analysis and design to make it an independent piece of software which can easily be plugged into other software to make an effective, reliable and efficient software for its customers. The next topic is object orientation. So this object orientation, which is consists of all the features of object oriented software. The first characteristics is the classes and objects. The class defines the structure of the object, which include attributes and operations. And next is messages, attributes, and methods. The objects are required to communicate with each other by passing the messages between the objects. So a message is a request for performing an operation by an object of the system. An attribute is the data of the class. A method is a sequence of steps or set of operations to be performed to complete the designated work. And next feature of object-oriented software engineering is encapsulation, which is otherwise called as information hiding, which means the data and operations are combined into a single unit. The next concept is inheritance. The subclass inherit the attributes and operations of the base class and have their own behavior. So here we have a relationship called as a specialization generalization relationship, which is also called as a Easter relationship. The next feature is polymorphism. That is, the same instruction is given to many objects across the classes, but responses of objects may be different. That is, in many forms. The next is responsibility and abstraction. The selection of an appropriate method is the responsibility of the receiver object. And an abstraction is the elimination of irrelevant and the amplification of the essential details. For example, to learn driving a car without knowing the internal details of the engine, batteries, control system, etc. So the abstraction may improve the understanding of the system and hiding the complexities of the system. Then object composition is the use of objects as data members in another class. So it has a relationship depicts in an object is declared as an attribute in another class. Thank you.